this project, we're going to look at how force effect motion and force effect can help us look at how levers work. I'm starting in force effect motion and checking my unit settings. I'm going to place a component and then change the length of that component to 10 meters. Once the component is placed, I'm going to put a support. And this is the pivot point for the lever. Change the value to 2 meters. So I now have an input length of 2 meters and an output length of 8 meters. I've added an actuator, and I'm going to change the angle of that actuator to 15 degrees. That's the rotation angle. Start the animation, and we can see that lever in action. Next thing I want to do is determine the length that A and B actually move. So to do that, I'm going to put a construction line in. And I'm going to make that 0.5 meters. At B, I'm going to put a second line in, and that's going to be 2 meters. And this will match the input length, output length ratio of 1 to 4. I'm just going to draw a line diagonally so you can see this in action. Start the animation, and you can see that approximately it's half a meter on the left, A, and 2 meters on the right, B. I'm going to add a trace to both A and B. Start the animation, and we can see velocity vectors are added because of those traces. At point A, the velocity is 5.58 meters per second, and at B, 22.32 meters per second. Now if I divide those numbers, I'll discover it's a ratio of 1 to 4, or 4 to 1. I've taken my diagram now into force effect. I don't need those construction lines, so I'm just going to delete them. So deleting all 3 of those lines. I'm going to modify the diagram. First thing I'm going to do is I'm going to delete that support. Then add in a short vertical support, another component. I've made it 2 meters long, but the actual length doesn't matter. Having placed that component, I'm going to fix the distance 2 meters from the left, point A. So distance A to C is 2 meters. I've added grounded support. That will enable me to do the calculations in force effect. Apply the force of 4 newtons. And I can see the torque is 8 newton meters. That's 4 times the distance of 2 meters, 8 newton meters. Now that I know the torque is 8 newton meters, I've gone back to my original diagram. AB, 2 meters to the left, the input, 4 meters to the right, the output. In this case, I'm adding a torque. I'm adding that value of 8 newton meters. Now you have to be careful here that the torque is actually located exactly at that pivot point. So I'm changing that value to be 2 meters. I'm also going to add another support. So on the right hand side at B, I add in that support, and when I do that, I get my resultant or reaction force of 1 newton.